Hello everyone, welcome back to 10th session of this IoT course. Last session I have demonstrated how to build IoT project by using NodeMCU, ThinkSpeak Cloud and DST11 sensor. Today I will discuss a new app that is called Blynk app for IoT. By this app we can design user friendly any application and you can connect any IoT device like Node MCU with sensor or Raspberry Pi, whatever you want.
Agenda of this session: what is Blynk, then what devices are supported, then how it connects, what can I do with it, how it works, common widget settings, and pros and cons.
Let's start. What is Blynk? Blynk is a platform with iOS and Android apps to control Arduino, Raspberry Pi and the likes over the internet. You can see guys, this is the screen or let's say interface of app. Guys, you can see the app interface from the picture. It is a digital dashboard where you can build a graphics interface for your project by simply dragging and dropping widget. As you know, Android is an app development tool, right? Where you can develop your app. But the problem of Android is basically it is very heavy and it is difficult to design a customized app because you have to know all these things. That means the Android programming, Java, and all these things. So, but in this Blynk app, you can easily design your app according to your wish, just only dragging and dropping. But most importantly, it is really simple. To set up all the required environments, server, client, board, 5 minutes are more than enough. Now, I'll come to the history of Blynk app. 16 January 2015 started the journey. 14th February 2015 successfully raised
$49,235.
USD. 27 March 2015 beta release. 12th May 2015 live. So that is the history of the Blynk app. What devices are supported? Arduino and the likes, that means Node MCU, whatever. Energia, particle, ARM model, right? And many more. This is the full list of Blynk websites. You can see. So for Arduino, then Arduino like, Energia, right guys? Just click on this link and get to know about the different website for different devices. How it connects? You can use Ethernet, you can use Wi-Fi or Bluetooth, low power Bluetooth, serial USB or 3G. What can I do with it? Everything regarding IoT. You can design any types of app and it is very lightweight. How it works? There are three major components in the platform. There is a Blynk app platform, Blynk app, Blynk server, Blynk libraries. Guys, you can see the picture. The first one is the Blynk app. You can see the mobile phone picture. Then you have the Blynk server, and lastly we have the Arduino, Node MCU, Raspberry Pi, and all, and also the Blynk libraries. So now you have to have the internet connection with your device, right? So your device, that means whether it is Node MCU or Arduino or Raspberry Pi, whatever be the device, it must have internet access through which you can connect to the Blynk server, right? And the Blynk server will connect to your Blynk app which is in your mobile phone. And now we can control your device remotely by using the Blynk app. Okay, but you have to use the Blynk libraries whenever you write program for this particular device like Arduino or Raspberry Pi or Node MCU, whatever be the device. That is the basic mechanism. Main operations. Blynk allows us to interact with pins like digital and analog, send and receive data from hardware. But how? With widgets. Four main types: controllers, displays, notifications, and others. Common widget settings. Pin setup, that means whether it is analog or digital. Data mapping, that means from virtual pin to actual pin. Split or merge. There are different controllers that you can see, guys. One is button, slider, timer, joystick. Displays, you have gauge, LCD, LED, graph, and many more. Notification, another. Email, bridge. Is it possible to run a local server? Yes, of course. Download the web server from the website, start the server locally, set up router to enable port forwarding, set the server from the Blynk app. Pros and cons. Easy and simple, already I told you, this easy and simple rather than the Android app development. Many features, no additional hardware, active community, cool GUI, that means user friendly GUI. These are the pros. Cons: lack of documentation for some devices, cannot make own widget, not made to implement complex projects. But whenever you want to implement very complex project, then this not be the solution. But guys, I'll recommend you rather developing a heavy, let us say, this Android app, you can design Blynk app for common uses. Now I will open Arduino IDE and show you that how you can write code for Node MCU and the Blynk app. So now I'll go to Arduino IDE. This is the code for connecting Node MCU and the Blynk app which is in your mobile phone. So guys, you can see already I've used this thing ESP8266 Wi-Fi.h. This is the library you have to use. Already I told you, you need Blynk libraries. And the DST.h, the DST library. And I have defined one Blynk print, that is the serial. So now you have to give username and password, that is SSID, and the password for your Wi-Fi. In my case, this is the username and password. And whenever we want to create a new project in Blynk or you want to design an app, so as soon as we create a new project, then from the Blynk app there will be one authentication token will come to your email address. That is the authentication token. I will show you when I will design a project in Blynk app. So this is the D5 pin where I connect my data pin of DST11 sensor. So guys, you can see this is the dst.read humidity and dst.read temperature for reading humidity and the temperature. And yes, I have printed this thing, temperature and humidity. And then if it is false, that means we are not reading any kind of temperature or humidity, it will print fail to read from DST sensor and return. And this is the blink dot virtual, right? These are the pins. This is called the virtual pin. You have to set in Blynk app. I'll tell you. I'll demonstrate you also. This is V5 for temperature and V6. If you remember this thing, V5 for temperature and V6 for humidity. I'll connect this pin, the virtual pin, to actual pin, or rather you can say I'll map it. So now this is the blink dot begin. We have to give the authentication token, right, and SSID, that is your username of your Wi-Fi, and the password. Then this is dst dot begin. So now this timer dot set interval. That's you can set up a function to be called every second. So this is the in loop function. We have blink run and time run function. Okay, so this is more or less the description about the code by which you can connect your Node MCU and the Blynk app which is in your mobile phone. Now I will show you how to download Blynk app from Google Play Store and design the Blynk app in your mobile phone for temperature and humidity monitoring. Now I will show you how to download Blynk app from Google Play Store in your mobile phone and how to design the Blynk app for humidity and temperature monitoring project. First, I will go to Google Play Store, then search Blynk. As you can see over here, open button. Why? Because already I have installed Blynk app in my mobile phone. That is what is showing open tab. So, but in your case, it should be installed. Okay. From this, you have to install the app in your mobile phone. Guys, you can see this is the Blynk app logo. I'll just click on that. You will receive a one interface where we have the new project, my app and community. Click on new project and give a name, project name, that is temp and temperature and humidity monitoring IoT. You can give any name whatever you want. So now guys, the interface is black, so you can change it to light also. I prefer light, that's why I'm clicking on light. Now create, click on create button and then OK. As soon as click on OK, you will receive one authentication token in your email address. As you can see, I have received one token. So just copy this token from here and paste it to in your code. Just select it. Please check once more whether you have correctly copied or not from your mail. Starting with K and ending with 6. Okay, correctly copied. So now I'll come back to app once again, and I'll add some components to display temperature and humidity. Just slide this thing and select gauge. You can take any display unit or display component. So I'm selecting gauge. You can see this is the gauge. Or we can also select gauge like this. So now after that we just select gauge or click on gauge and name it. What is the purpose? I think temperature, right? And the select pin. So I told you that here you have to select the virtual pin. So select virtual, and for temperature virtual pin should be V5, because I have written over here virtual pin for temperature is V5. So that's why I select V5. Then OK. Then click on push and select the refresh rate. You can select 1 second or 2 seconds. I'll select 1 second. Then OK. Then you can write the unit for temperature. So it should be centigrade. Then back over. So guys, you can see here this is temperature is written, and the maximum value is 0 to 1023. Okay, you can see guys 0 to 1023. Okay, leave this thing intact. 1 second back. So accordingly you select the second one for humidity, write the name humidity, then select the pin as virtual and V6, because I have selected V6. You can see guys in quote humidity V6 virtual pin. Okay, the range keep it intact 0 to 1023. Then write the unit, is percentage. Then click on push and select the refresh rate. For my case is 1 second. You can also give 2 seconds, doesn't matter with that. Go back. So design completed. You might have noticed that at the top 200 is written. That means what? Blynk app is not totally free. They are giving 2000 points free. Whenever we are adding any component like button, gauge, timer, whatever, they will deduct some point. But total available point is 2000. Suppose we have added one button and one slider, there may be deduction of some amount of point. That means 2000 minus that amount of point. Okay guys, so be careful about that. Now I will introduce different components which are required to build the project. This is
node MCU or ESP8266 module. This is a microcontroller board which has ESP8266 Wi-Fi SoC, that is single on chip. Within this module, there is a processor called LX106, which is a 32-bit RISC processor. Here, already I told you that this board has 17 GPIO pins. So these are the some GPIO pins. This is the port through which you can connect USB cable with this board and your computer or laptop. This is the antenna, that is 2.4 gigahertz. Antenna is embedded over here for connecting to your Wi-Fi. So now this is a DST11 sensor that senses temperature and the humidity. It has three pins. Positive, data pin and negative. Negative means ground, positive means 5 volt or 3.3 volt. So guys, you can see the wires. The orange one is connected to positive, that means you have to connect this orange wire to 3 volt of this node MCU board. Now this brown wire is connected to negative pin of this DST11, and you have to connect this brown wire to ground pin of this node MCU board, and the red one is connected to the data pin, and you have to connect this pin to D5 pin of this node MCU for this project. So this is the DST11 sensor. Now this is micro USB type B cable, USB cable, through which you can connect this node MCU board and the laptop or the computer where you write the code and where you have the Arduino IDE. And through this cable, you can upload the code from your computer to this board, or you can say the flash memory of this board. Now I'll assemble these components according to circuit diagram. First, I'll connect DST11 sensor to this board. So already I told you this orange pin is positive pin of DST11 sensor. So I'll connect this jumper wire 3 volt of this node MCU board. Then I'll connect the ground pin to this ground pin of node MCU board. Then after that I'll connect the data pin, this middle one, you can see the red one, to D5 pin. This is D0, this is D1, D2, D3, D4 and D5. This is the D5 pin, guys. You can see from here also. This is D5 pin. Where I have connected, this is D5 pin. This is 0, 1, 2, 3, 4 and 5. So then after that I'll connect this micro USB to this port, and this part of this micro USB I'll connect to my laptop.
Now I'll connect my device, that is NodeMCU and the DST11 sensor with this app. So to do this one, I have to execute this code. Already I have explained this one. Okay. So already I told you this is Blynk print serial, because I have written here serial.print. Okay, that is why just I have defined it earlier. For printing something, we are using serial.print or print ln. So already I have explained all these things to you guys. The most important thing is the authentication token. For each project there must be a one authentication token. Okay, and you receive in your email address, and this is the username password of the your Wi-Fi. So, and I have connected D5 pin of this device, that is the NodeMCU, with sensor pin, that is sensor data pin. Okay, so now I'll go to tools, select the board already selected, NodeMCU 1.0 ESP12B module, select the port already selected. I'll select once more and click on compile and upload. Guys, you can see compilation is going on. Compilation is done. Uploading is going on. Done uploading. I'll check from serial monitor whether this application reading data or not. Yes, it is reading data. You can see, guys, 28 degrees temperature and 57 is humidity. So now I'll play the app. Guys, you can see from here temperature is 28.8 degrees centigrade and 57% is humidity. So that is the way we can design an app and install in your mobile. As you can see, the output, it is 28 and then 57. Thank you very much.